Hello, our first video on calculus for specialist maths. So here we go, calculus. The most important thing to remember whenever you're doing calculus is that what a derivative means. The derivative means at any point on this graph, the derivative is merely its gradient. Okay, so at any point, the derivative is the gradient at that point. So it's really important to remember at any point the derivative is the gradient. So just keep that in mind, and the gradient, so I'll just write that down. So if you've got graph y equals f of x, then f dashed of x, which is the derivative, will tell you that's the gradient at the point x. The gradient. So, and gradient tells us the rate of change. So always think of the gradient as the rate of change. How quickly is something changing with respect to another variable? It could be time, it could be distance, it could be anything. So that's important to remember. And so just the common derivatives. If you've got f of x there and f dashed of x there. So the derivative of any constant is 0. The derivative of any x to the power n is nx, n minus 1. And the derivative of sine x is cos x. The derivative of cos x is negative sine x. That's the one I always have to just stop and think about. Just be careful with that negative. The derivative of e to the power x is e to the power x. And the derivative of log base e of x is 1 over x, where x must be greater than 0 because of the function log e of x. It's only defined for x greater than 0. And that's all of them. I'll just put also tan x down here, but you can find this one. Derivative of tan x is sec squared x. Okay, so there's all your sort of your basic ones, and we use these to find more complicated ones. Okay, so the three sort of rules that help you out of trouble in most situations are the product rule, quotient rule, and chain rule. They're the three rules. Okay, and what they are is that if you have two functions u and v, and so if you've got, let's say you've got y is equal to some function u times some function v, and they're both functions of x. Okay, so if you've got two functions there, then you write down u equals something, v equals something, and over here you could write your derivative of u equals something, derivative of v equals, and dy by dx will be equal to this one. I'll just use red pen. This one times this one, so v u dash, plus this one times this one, so it's u v dash. So that's the product rule there. Okay, so if you always write it out like that, it makes it actually quite easy that you're sort of going across like that. And particularly for the quotient rule, I'll show you why I do that. So the quotient rule, same thing. If you've got y equals some function of u divided by, u, which is some function of x, divided by v, which is some function of x. So two functions divided by each other. That's why it's a quotient rule. And if you write them out, u equals something, v equals something, and so you have u dashed equals something, v dashed equals something, then if you do this little tick thing, you do a tick and go up like that, then the quotient rule tells us that the derivative of y with respect to x is equal to, you start with the one where the tick is, so you start with v times u dashed, that times that, subtract, and that's why this order is important, and you subtract the other two, so u v dashed, and you divide it by wherever the tick starts, squared, so v squared. That there is our quotient rule. Okay, I'll give you examples of that in a second. Chain rule. I might do a separate video on because it's just so important. So I'll just do a couple of quick examples of product rule and quotient rule, and then I'll go on to the chain rule in a separate video because I just want to, I'll probably spend a bit of time on that. So, an example of, well, I won't say what it is, okay? So let's say y equals e to the x sine x, something like that, nice and simple. To find the derivative of y, what we've got is we've got two functions times by each other. We've got this function here, e to the x. I meant to change colour there, didn't work. We've got this function here, e to the x, and we've also got this function here, sine x, and they're multiplied by each other. So that tells us we need to use the product rule. We've got some function of x times another function of x. So what you do is you use the product rule. You write down u as your first function, you write down v as your second function, and write down your derivatives. What's the derivative of u? The derivative of e to the x is just e to the x. Nice and easy. What's the derivative of v? The derivative of sine x is cos x. And if you want to do this, you can, but you don't really need to for product rule, but it might just help you. Therefore, the derivative of y with respect to x is equal to this times this, so it'll be e to the x sine x, so that times that, plus this times this, and you go the other sort of diagonal, plus e to the x cos x. And that's your answer. If you wanted to, you could take out e to the x and write it like this. Up to you whether it makes it simpler or whatever. Okay. So there you go. So there's the product rule. Nice and simple. Let's do an example of the quotient rule. So we'll do find the derivative with respect to x of log e x times tan x. Okay, so find the derivative with respect to that. Okay. So what we've got, sorry, I want to do a question I'm doing, so I'll just change that. Just filling stuff up. Log x over tan x. Let's do that. Find the derivative of that. So firstly, write down what have you got? Well, you've got a function of x divided by another function of x. So we need to use the quotient rule. So if you write down the noisy birds, u equals the top line, so log e x. V, which is the bottom line, which is tan x, so that's the function of the bottom line. So you write your u and your v down. Now take the derivative of both. The derivative of log e to the x is 1 on x, and the derivative of v is sec squared x. That's squared, okay? Sec squared x. And so just be really, really careful with the quotient rule. Always, if this helps, then do this, but just make sure you get the order right because people get these muddled up quite the time. So the derivative of, well, we haven't actually defined y, so just be careful there. So therefore, the derivative with respect to x of, this is all about just notation. At the start of the question I could have said let y be equal to this, and I could have used y down here, but I haven't actually defined it. So I'll just leave it like this. So the derivative of that with respect to x is equal to, and it's going to be, remember with the quotient rule, you do the tick and you go this times this first. Okay, so it's going to be tan x times 1 on x minus this times this, minus sec squared x times log e x. All of that divided by, wherever the tick starts, squared. So it's going to be tan squared x. Okay. And could you simplify that? You'd write that as tan x over x. Sec squared. It's actually not very nice. Nothing much could happen to that. You could try and simplify that. I'm not going to look at it now, but really, you could. It's not going to be nice because I made up the question. It hasn't turned out very nice, but it's okay. You know, minus log ex over cos. Nah, nothing very good happens here. So no, I'd probably just leave it like this. So don't worry about trying to expand it or doing anything funny. Yeah, you get it there. No, nothing good. So that's the product rule and the quotient rule. Next video I'll do the chain rule.